Let's talk about gold for a second. I mean, think about it. It's not just that it's shiny and, valuable. It has these qualities that feel almost magical, and they've captivated us for centuries. Well, it turns out the secret behind gold is actually the secret behind, well, pretty much everything. So first off, gold is what we call malleable. That means you can hammer it into a sheet so thin it's practically see-through. It's also ductile, which means you can stretch it out into a tiny wire and it won't snap. On top of that, it's a fantastic conductor of electricity, and it's so tough against chemicals that it just doesn't rust or tarnish. Ever. So that's the real question, isn't it? What is going on that gives gold the specific, unique identity? Why isn't it like a piece of iron or like the oxygen that we're breathing right now? Well, the answer is way simpler and honestly way more profound than you might think. To really get gold, we have to look at the basic secret that's behind all complex materials. And it all comes down to this one simple concept, an element. So what is it? An element is a pure substance that you just can't break down into anything simpler. That's it. It's the end of the line. It is a fundamental ingredient of the universe. And that's gold's secret. It's a pure element. All those incredible properties we were talking about, the shine, the strength, the resistance, they all come from the fact that it's made of just one single fundamental ingredient. But what does that really mean, when we zoom way in? All right, now we need to zoom in. I mean, way, way in, past anything you can see with your eyes, to figure out what makes one element, like gold, so totally different from another. Okay, so we've arrived at the atom. The atom is the smallest possible piece of an element you can have. And here's the absolute key. Every single element has its own unique, one-of-a-kind type of atom. It's like a tiny identity card that makes it what it is. So a gold atom is just fundamentally different from an oxygen atom, which is different from a carbon atom. It's this difference right down at the atomic level that creates all the variety we see around us. It's why gold is a shiny, heavy metal and oxygen is a gas we can't even see. It all comes back to the atom. So, if everything is made of these fundamental ingredients, how many of them are there? And how in the world do scientists keep track of them all? Well, let's take a look at the universe's master list. And when I say everything, I mean everything. You, me, the device you're watching this on, the planet, the stars, all of it is made up of the atoms of at least one of these elements, all mixed and matched in endless combinations. Now, with all that incredible complexity, you'd probably think there must be thousands or millions of these basic ingredients, right? But no. The mind-blowing diversity of our entire universe is built from a list of only about 100 elements. That's it, just around 100. And the incredible tools scientists came up with to organize this list is the periodic table. It is so much more than just that chart in your old science classroom. It's the ultimate master list for all of chemistry. And it doesn't just list them, it actually groups them together based on similar properties, which makes it an unbelievably powerful guide. Let's see how that organization works. The periodic table shows us these big, obvious patterns, and we can start with the two main families of all the elements, the metals and the nonmetals. So most of the elements are actually metals, just like our old friend gold. They tend to be shiny, and they're really good at conducting electricity. Then you've got the nonmetals. A lot of these are gases at room temperature, think oxygen or hydrogen, and they're not shiny, and they don't conduct electricity well at all. But of course, nature loves to have a few exceptions to the rule, right? So we get these really fascinating oddballs. For example, mercury is a metal, but it's a liquid at room temperature. And while most nonmetals are gases, you've got carbon and sulfur, which are solids. These little quirks are honestly part of what makes chemistry so cool. So when you really stop and think about it, everything, from that single beautiful piece of gold we started with, all the way to the invisible air that you're breathing in right this second, it's all just different combinations of those same 100-ish elements on that one table. So I'll leave you with this thought. Just look around you. Right now, the iron in your building, the silicon in your phone, the carbon in your desk, the oxygen in the air. How many of the universe's ultimate building blocks can you spot just sitting there,